Okay, chaliye. So we'll start with thermal physics, and in thermal physics, the initial part is something that there is no point in me teaching again. We have learned that in detail in what you call gray in chemistry, and that those the topics I'll tell you. It talks about properties of solid, liquid, and gas. What is a particle model? So I will touch the portion which is more from numerical and more something that is new. Earlier, these used to be covered under the gas laws. Now they don't cover as gas laws, but the topic is same, and that should be, you should know this in order to study physics, and even this will be again repeating back in chemistry. Okay, so we start our discussion. We start our discussion with gases. The initial part of solid and liquid, all those we know. I don't think we need to learn again what is cooling, what is condensation, what is melting. Those are all known to us. Ahiri, join 5 minutes before time. Okay, it's a class, it's not a movie. I mean, that at 7 o'clock you enter with popcorn. है ना? Ashmita 3 बार सुन चुकी है ये बात. So then we can discuss what is happening and what is not. And in fact, you are joining late also. It's beyond 7. So we discuss about gases, and we will see whenever we are talking about gases, this will be coming in your later subjects of chemistry also. The topic that is important for gases is 3 parameters we generally use. One is known as pressure, one is known as volume, and one is known as temperature. Okay, in our short, we call these 3 parameters as P, V, T. It is of utmost importance for us to understand how does PVT relate for a particular gas and what are the conditions and what not. ये हमें जानना बहुत जरूरी होता है. Before that, we need to also understand the temperature scales. The temperature scales. So we are usually what you call habituated using the scale of Celsius. हम Celsius use करते हैं day to day में, right? But in chemistry or in science, we use the absolute scale of temperature. Absolute scale. And you will be doing all your problems on absolute scale, and this scale is known as the Kelvin scale. Let us first understand what is absolute scale. So if you have matter, say I have a gas, this gas comprises of many what is known as particles. Okay, and what are particles? Particles are usually atoms or molecules, okay, or ions, or can be even electrons, right? These, when we say about particles in kinetic theory of matter, these are the particles that we refer to. So these particles, there are various particles out here. These particles are always in what we call as random motion. They are in random motion. Random motion means these particles are moving around. They are moving around, but there is no particular order in which they are moving. So you may ask, sir, how do they move around? As they wish, either ja sakta hai, idhar ja sakta hai, idhar ja sakta hai, idhar ja sakta hai. The way they move, this is called random motion. But what is more interesting for us is that they are moving around, say we conclude that they are in motion. So when they are in motion, these particles are associated with something which is known as kinetic energy. Okay, the particles of gases are also not gases, even solid, liquid, all states of matter, they are associated with kinetic energy because they have a motion. Now, when we talk about gases, this particular motion is more random. This is more random. But if we talk about liquid and solids, this motion is more controlled. In solid, the motion is heavily controlled. You just can't move around as the way you want. Whereas in liquid, you can move to some extent. But in gas, you're just like left alone in the playground. You just move around random. So when we talk about the particle's motion, this particular particle, there are 2 types of motion that we see. One is that this particle vibrates at its own position. Okay, this is vibrates about its position. This is one sort of motion that we see. Vibrates about its position. This motion is seen in solids also. And in gases, the particle may also move around. That is one additional motion that we are having. Rather than moving about its position, it also vibrates. So just understand, if I am a particle of gas, I do have a vibratory motion around my position, and in gases I am also moving around, but in liquids and solids that movement is restricted, but this movement around its position is always there. That means that whenever it is vibrating, this particle is associated with energy. नहीं तो ये तो move ही नहीं कर पाएगा. This particle associated with energy, and this energy is nothing but the kinetic energy. Okay, the kinetic energy of the particle. Now start thinking. When a particle, okay, now this much we have understood, that as the particle vibrates about its own position, the particle has got some amount of kinetic energy. So let us see a sample of matter. Okay, let us see a sample of matter, and let this be solid for a time being, so that you get a hangover of everything. Let this be solid. So I have particles here also. Though the particles are not leaving their position, these particles are definitely vibrating about their own position. At this moment, the energy that this system has is always known as the internal energy of the system. System ke andar we will have some sort of internal energy, and the word we use for this is known as enthalpy. Please understand, whether this chapter has this word or not, in chemistry you're going to get this word. Enthalpy is the internal energy associated with this system. So when we talk about, say, solids, the enthalpy is less. If we say liquids, the internal energy is more. In gases, the internal energy is much more. Okay, this much of internal energy is always there with an object. See, we were discussing about temperature scale, absolute scale. So where does the absolute scale come from? In order to understand that, we should understand the motion of the particle and the kinetic energy associated with it. Now what I do, I start heating this gas. Okay, I start heating this gas. So what will happen? The heat energy which comes here will increase the kinetic energy of every particle. So as the kinetic energy of the particle increases, the particles will all move with much more motion. And once you heat, what happens? The temperature of the gas is going to go up. All our intention in this chapter is to study this temperature and kinetic energy and find a relationship between them. See, we are trying to understand what is the relation between the kinetic energy and what is the relation between temperature. पूरे चीज को फिर से समझिए. I have got a sample of gas. This sample of gas has got gas particles in it. Every particle vibrates about its own position and also moves about. But if I see a solid, the particle only vibrates about its own position. That's why solids have a definite shape. They don't move around. This basic amount of energy with which a particle is associated with is called its internal energy, or we call it as enthalpy of the system. That much energy is there. हर एक system के साथ enthalpy है. Even if it is a Cadbury's Dairy Milk right now lying there, the particles are vibrating about. But in case of gases, the enthalpy is much more. Now above that, you are trying to heat it externally, so you're supplying energy and you are increasing the kinetic energy of these molecules. So our job is to see what is the relation between temperature and kinetic energy. Based on this, we have one thing we can say, that if you increase the temperature, the kinetic energy increases. Obviously. How do you increase the temperature? Sir, I increase the temperature by heating. Can I rub this portion for a time being, or do you want to keep it aside? Let's keep it aside, okay? Let's keep this aside and take the discussion a little bit more further ahead, okay? So, right. So we say that I have got a parameter now, and the parameter is temperature. I also have a parameter which is kinetic energy. Now I'm trying to find a relation between the two. Okay, somebody says at a very basic fundamental level, if you try to define what is temperature, I will say temperature is a measure. Temperature is a measure of the degree of hotness or coldness of a substance. Okay, hotness or coldness of a substance. Now this is very kiddo definition. Let us make it a little bit better. This hotness or coldness is nothing but you are trying to measure. Temperature is an indicator of the heat content of a body. बच्चा ये समझ में आया कि नहीं? See, first we were going with a very basic definition. What is temperature? Temperature is the degree of hotness or coldness of a substance. Making it a little bit more mature, we say temperature indicates the heat content of a body. Obviously, if you have more heat, the temperature will be more. If you have less heat, the temperature will be less. Now, the connection between these two is very interesting. Okay, we say that the temperature is equal to the average of the kinetic energy associated with the particles of a substance. अच्छा, temperature क्या है? Temperature is the average of the kinetic energy associated with the particles of a substance. That means if I have a substance and I have n number of particles inside it, मेरे इसके अंदर n particles हैं, and say these are my n particles, okay, and this has a kinetic energy which is Ke1 and this is Ke2. So my temperature is nothing but summation, this is called sigma, summation of all the kinetic energies, okay, divided by the number of particles that you have. And we actually put a counter here. You need not memorize this definition. It's like 1 to n. So I say Ki. How I read it? Temperature is the summation of all the kinetic energy. Ki means Ke1, Ke2, Ke3, Ke4. Add up all the kinetic energies and divide by the number of particles. That's actually temperature. Which means that if the temperature of a gas is high, then I would say not Ke, I would say that the average Ke is also high. Does that make sense now? If the temperature of a gas is high, the average kinetic energy is also high, because temperature is a measure of the average kinetic energy of the particles. Why are we having this discussion? We started our discussion from the absolute scale of temperature. So the question next comes to our mind is that, sir, you have been talking all about heating. What if I reduce the temperature of this gas? I would say that the average kinetic energy will also reduce. Obviously, if you reduce the temperature, that means if you cool a gas, the gas is no more that naughty to wander anywhere around. है ना? So सोचो, if you cool a gas, the gas is not that naughty that it will wander around. तो आप गैस को cool कर रहे हो. That means you are releasing the kinetic energy. बच्चे से एनर्जी निकालते जा रहे हो. Then we start saying, to what extent can you cool it? So hypothetically, I would hypothetically say that you cool till the average Ke becomes 0. Try to understand, bacha. You are cooling a gas. This is theoretical. Maybe itna cool hum kar hi nahi payenge. You are trying to cool it so much that the average kinetic energy of every particle is now made 0. Means ऐसा करने के बाद you have a matter, I am having a matter whose particles are almost dead now, dead in terms of motion. Their Ke is equal to what? 0. This is not possible in reality. See, gases is a very interesting part in physics. This is not possible because the kinetic theory of matter tells us every particle is associated with some bit of energy. And here we are trying to say that we are going to reduce the energy so much that we make the average energy 0. So ये कैसा है? This is like a hypothetical scenario. क्या ये practically हो सकता है? Sir, practically करने के लिए I should have the kinetic energy of all the particles as 0. That's not possible because the kinetic theory of matter doesn't say that. The kinetic theory of matter says that there is always a kinetic energy associated, and that is called the internal energy of the system, which is called enthalpy. And thermodynamics, आगे अगर आप पढ़ेंगे, you will read that enthalpy cannot be 0. You can't make the internal energy 0. But hypothetically, I can think like this. Let me give you an example. One maid takes 1 hour to clean my house. I double the number of maids. I expect that the house will be cleaned in half an hour. I quadruple the number of maids. I think my house will be cleaned in 15 minutes. Let me make the number of maids 10 in my house. Do you think they can at least clean the house also? No. They would be knocking against each other only. And how about making 50 maids in my house? As a mathematical model, the time taken to clean my house should be now less than 1 second or 1 minute. But is that possible? That's not possible. But hypothetically, that is possible. So this concept where you actually bring the average kinetic energy zero, at that time, there would be some temperature. And that temperature is actually the absolute temperature which we measure in Kelvin. ठीक है? थोड़ा इसको छोटा करते हैं, and now we'll take our discussion from this point. So what is our discussion now? Our discussion is that, okay, let me make this also smaller and let me give this here. Okay, इसको यहाँ रहने देते हैं. Let's see what we have discussed so far. So far we have discussed, okay, so far we have discussed that temperature is a measure, this should be very clear with you, measure of average kinetic energy, right? That means, and we are going to study something which is this thing, absolute temperature. What is the absolute temperature? So there comes a concept of something called absolute scale of temperature. Absolute scale of temperature means a new scale of temperature which will be absolute. What does the word absolute mean? That means this scale of temperature starts from a rock bottom. ऐसे ही तो कोई scale शुरू होना चाहिए ना. It should start from something called zero. And this scale is measured in Kelvin, not degree Kelvin. We just write Kelvin by the capital letter K in the honor of Lord Kelvin. That means this temperature scale starts something from 0 Kelvin. And 0 Kelvin is known as the absolute zero. Absolute zero. इसका definition क्या है? What is this 0 Kelvin? Sir, at this temperature, we have assumed that the average Ke has become 0. Is it possible? No, sir, it is not possible. But somewhere we have to say what is 0. So this is the absolute zero. So you can now ask me, sir, have we ever been able to attain absolute zero? No, not possible. नहीं जा ही नहीं पाते वहां तक. उससे पहले ही गैस ठंडा उंडा हो गया खत्म हो जाए. ठीक है? So in all engineering analysis, if you see we have got 7 fundamental units, out of which 1 unit is given to temperature, and temperature is measured in Kelvin, not degree Celsius that you use in everyday life. Like you say the temperature of Hyderabad today is 31 or 32. That's degree Celsius. We're not going to use that. We are going to use Kelvin, Kelvin, Kelvin. So what is Kelvin? Kelvin is an absolute scale of temperature. Starts from absolute zero, the point where it has been conceptualized that the internal energy of the system has become zero. No kinetic energy is associated. इतना ठंडा कर चुके हैं, इतना ठंडा कर चुके हैं कि none of the particle have any energy associated with them. Why is that criteria so important? Yes, because we said temperature is equal to the average of kinetic energy. No particle can contribute any kinetic energy. Reality may not possible. Does this make sense now? Have you understood what is absolute scale of temperature? If you have understood this, now our time is to understand the conversion between the different temperature scales. Okay, ready? Can I rub this now? Okay. Okay, chal. So I'm rubbing this and let's understand the different temperature scales. Whether it's there in your book or not, you should understand the temperature scales. Now in our daily life, we always use something called degree Celsius. Okay, degree Celsius. And degree Celsius, देखो इसको हम कहते हैं degree Celsius. We read it as degree Celsius. And sometimes you will also see somebody saying degree centigrade. ये सब difference समझना है आज. Then we also have something called, okay, water boils at what temperature? 100 degrees Celsius, right? And God forbidden, when we have viral fever, we are having temperature around 101, 102. Now, if we are a little bit ahiri, answer karo, huh? No one else answers. If someone is, say, doesn't have any mercy, I'm someone who doesn't have any mercy. On that day, Ahiri is lying on the bed and she's at 102 viral fever. Why don't I put my cup on your forehead and heat the water? Think, don't Google. इधर ही देख के आंसर करो. हाँ, My question is that you can unmute yourself. Your temperature right now on your body, we have measured you. You're measuring 102. You are absolutely down with fever, and we are taking a hypothetical scenario where I am actually trying to make a cup of coffee on your forehead because water boils at 100 degree. Why am I? वो होना चाहिए नहीं होना चाहिए? What is your understanding? You're muted.
Sir, can you hear me now?
Yeah, I can hear you now. What is your point of view? You're having fever. Why am I not putting my coffee cup on your forehead? ठीक है ना? गैस बच जाएगा थोड़ा सा.
Could it be because the temperature in our body is different than what?
How can the temperature be different? Temperature is temperature. How can it be different? You are having fever of 102. I want to enjoy a cup of coffee. I'm putting my coffee mug on your forehead. Am I allowed to do that or not?
That's not possible.
Why? Why not possible? Otherwise, you are blatantly lying that you are having fever of 102. The thermometer has read it 102. So that means you are suffering from 102. Yeah, kahan pe gap hai? That's because the temperature that you are measuring in your body is measured in a unit called degree Fahrenheit. And when you make your cup of coffee, you are making it in degree centigrade. Two are different scales. ठीक है?
So, for our body
नहीं, Fahrenheit is a scale which worldwide is used for all clinical purpose except the United States and Caribbean and Cuba. यहाँ पे daily is also in Fahrenheit, like daily temperature. You won't see a American guy telling you that the temperature is 31 degrees Celsius. They'll say it's 100 and so, or it's 100 and something. That's because they are referring everything in Fahrenheit. So our first job should be to understand the difference between Celsius and Fahrenheit. ये सब बेसिक अगर आप नहीं समझेंगे और आप सिर्फ प्रॉब्लम करते जाएंगे तो you will just become a dumbo. ठीक है, आइए देखते हैं. What is the difference between Celsius and Fahrenheit? First, the two scales. Both the scales, whenever we design temperature on two levels. Okay, these levels are known as ice point of water, ice point, and another one is known as boiling point of water. Okay, so on the basis of water, this is my degree Fahrenheit and this is my degree Celsius. आज ऐसा टेक्निक सिखा दूंगा ना कि you can go and talk to any American and in 1 minute you will be able to convert temperatures. आपको गूगल करने की जरूरत नहीं, सिर्फ इतना बेसिक याद रखो that as per the Celsius scale, this you know, water forms ice at what? 0 degrees Celsius. Okay, इतना तो आपको पता है, 0 degrees Celsius, and water boils at 100 degrees Celsius. Is this perfect? All of you know this, right? And if you go by Fahrenheit, this you will not know. Fahrenheit में the ice point is taken as 32 degrees Fahrenheit and the boiling point is taken as 212 degrees Fahrenheit. ये आपको बेसिक इनिशियली याद रहना चाहिए. Water's freezing point in Fahrenheit scale is 32 and in Celsius is 0 degree. ठीक है? All the Americans work here. वो अलग होता है ना दुनिया में. And we work here except clinical. Whenever you are in a hospital and somebody says your temperature, they're giving your temperature in Fahrenheit. Now look, what is the difference out here, right? Let's look at the difference at this level. If you see on this side and on this side, if you see the differences, this is a difference of 100 and this is a difference of 180. ठीक है, इसका difference है 100, इसका difference है 180. Understood? That means Fahrenheit is reporting more. So whenever you are trying to report for degree Fahrenheit, how do you say that one division on the Celsius is 1.8 divisions on the Fahrenheit? Have you understood the calculation? 100 is to 180 means one division is to what? One division is to 1.8. So a degree Fahrenheit will be always 1.8 times a degree Celsius. Wait, don't start writing. लिखने से क्या मजा ही नहीं आएगा. आप इसको देखो ना तो record हो रहा है. That's a different point that you guys never watch video recordings. If you want to enjoy science, enjoy the board. What are you writing? If I write here 2.8, you will write 2.8. Yes or no? You're just believing me randomly. If I write here 3, you will copy 3. Yes or no? चलो थोड़ा सा मजा लेते हैं. Degree Fahrenheit is Santa Claus multiplied by Mickey Mouse. चल लिखो. Write down. तो कॉपी करने की आदत है ना. So copy this one also. अरे साइंस पढ़ रहे हो कि क्या पढ़ रहे हो यार? Such a nice syllabus you all have got. Such a beautiful syllabus you all have got, and you don't study it properly. So degree Fahrenheit, if you see 1.8 is one out here. So degree Fahrenheit is 1.8 times degree Celsius, but we are not yet done. We are not yet done. Comparison would be correct if you would have started apples to apples. But if you see this race, when this fellow was at 0, this fellow is already at 32. बात समझ में आ रहा है? So you have to take care of this correction factor also. So we write another 32 out here. This is the exact conversion of degree Fahrenheit to Celsius. Now if you Google it, Google will give you the answer as 9/5 degree centigrade plus 32. लोग इसको याद करते रहते हैं. People memorize this. But I tell them, if you memorize this, you will again forget because your basic is not clear. But if your basic is clear, then you will always go with this funda. And this funda will help you now. Just see. Any Fahrenheit measurement is 1.8 times the degree Celsius plus 32. Have you understood? This is the exact measurement. Now, let's take a hypothetical scenario where we have one person and we have another person. Now this person is from US and you are from India and you are having a chit chat, right? And you start saying, it was very hot in Hyderabad, 41, we switched on AC. And this fellow says, 41, that's quite cool. Are you giving air conditioners on? Because this fellow is talking in Fahrenheit and you are talking in Celsius. But then as an Indian, you are supposed to show your street smartness. Now, I can't expect you to, at that time, in your mind, multiply 1.8 and add 32. So, what is the temperature in Hyderabad? 41 degrees Celsius. You want to convert it in Fahrenheit. यही तो साइंस का कमाल है. आप इसको roughly 2 ले लीजिए और इसको 30 ले लीजिए. 41 converted by 2 is how much? 82. 92, 102, 112. So, it's 112 Fahrenheit. पटाख से. And you tell him, it was 112, 1-2. You're gonna hit the beach on that day. It's pretty hot. तो समझ में आ गया उसको. That is the power of you in order to understand how to decode quickly. And that fellow will suddenly tell you, oh, we went to the East Coast, and it was 50, damn cold. आप बोलते हो 50, sir, in 50 we are sleeping on the terrace of our house. He's talking in Fahrenheit. How do you convert it quickly? Quickly, it will not be accurate. यहां से 30 निकाल दो. कितना हो गया? 20. और 20 को 2 से डिवाइड कर दो. 10 degree. Oh, sir, exactly like Delhi, sir. Quite cold, sir. Are you able to understand? The exact measurement is 1.8 into this plus 32. But when we talk across friends, we can take it as 2 plus 30. That's how you understand things. Now we have to introduce, now this is Fahrenheit, this is Celsius. Okay. How many divisions did you see? 100 divisions. 100 divisions. That means another word I can add for this is 100 gradings. 100 gradings. 100 का दूसरा नाम होता है सेंचुरी, जहां से आता है सेंटी, और सेंटी का ग्रेड है. इसीलिए डिग्री सेल्सियस को हम सेंटीग्रेड बोलते हैं. Why do you call it centigrade? Because a degree Celsius is a scale which is graded on 100 divisions. It's a 100 divisions graded scale. That's why you call it degree centigrade. It means the same. but actually you are referring to degree Celsius. Now, is this clear between what is Celsius, the difference between Celsius and Fahrenheit? Fahrenheit is a scale which we use for clinical purpose in India, never used in lab. There are 4 scales: Kelvin, Celsius, Fahrenheit, and Romer. We generally use Fahrenheit, Celsius, and Kelvin. So our job is to understand Kelvin now. So we have to introduce one more fellow called Kelvin. So let's introduce Kelvin also in the scale. So Kelvin scale is out here. See, hang on. Sorry. So the Kelvin scale is out here. This is Kelvin. Kelvin में the numbers that we have associated is that when it is 0 degrees Celsius, it is 273 Kelvin. We don't write degree Kelvin. And Kelvin is also a centigrade scale. So Kelvin is also a 100 division scale. That means when you reached 100, boiling point in Kelvin will be 373 Kelvin. Have you understood? 0 degrees Celsius is 273 Kelvin. And in chemistry and physics and all, we are supposed to go by this scale. And this scale is known as our absolute scale. And in absolute scale, sir had taught that we should attain something called absolute zero. That means we should go more below this. Iske niche aur jana chahiye. And somewhere we will reach something which is known as our absolute zero. So here we have what is known as 0 Kelvin. This is a very hypothetical temperature. ये आप reach नहीं कर सकते हो. 0 Kelvin, when you have reached, then your mind, because you always measure in Celsius, you would like to understand how much is it in Celsius. Then you say this is negative 273 degrees Celsius. The last cooling that we could do is up to something around 80, 90, 120. We cannot go to this temperature for any gas. Not possible. But hypothetically, we say that the absolute scale starts from 0 Kelvin, which is negative 273 degrees centigrade, and it's always a centiscale. Acha. When we do problems on heat later, then you will find that the difference is always same. What do I mean by that? Let us try and understand one more thing out here. Okay, let's take 2 differences. Let's say this is one temperature and this is one temperature, right? Let me say arbitrarily that this is 10 degrees Celsius. So if this is 10 degrees Celsius, how much this should be? 283 Kelvin. 0 stands for 273. And let's say this is 30 degrees Celsius. If this is 30 degrees Celsius, then this is 273 plus 30. That means 303 Kelvin. What is the difference here? What is the delta T? The delta T is, sir, 30 Kelvin. What is the delta T here? So the delta T is 30 degrees Celsius. Whenever you take difference, this is a big thing. ये note करके रखो. Whenever you take difference between, because Fahrenheit में कभी problem नहीं आएगा. The problem will always be between these 2 scales. Whenever you are working in a difference of temperature, then you need not convert to Kelvin. A difference in Celsius is same as the difference in Kelvin. A difference in Celsius is the same difference as in Kelvin. जो करके दिखाया ना, 30 minus 10. So okay, so sorry. Yeah, the difference. Yeah, ठीक है, 0 degree, 10 degree. So if you 1 minute, children. One small mistake that I've done. Just give me a minute. 1 minute, huh? So let's say this is how much? 10 degrees. This is 30 degrees. So what is the difference? The difference is 20 degrees Celsius. So 10 degrees stands for 283 and 30 degree will stand for 303. So here also the difference will come 20 Kelvin. 20 Kelvin, 20 degrees Celsius. Just a little bit off topic, because in the chapter of heat, we will study a formula called Q equal to MC delta T. ऐसा एक formula आएगा in future. Delta T stands for the difference in temperature. Deliberately, the book will give you the temperature in Celsius. And like an idiot, you will convert into Kelvin. Not necessary. Because delta T, whether you are in Celsius or Kelvin, always remains the same. That's why you should know that. Kelvin is also a centiscale. Celsius is also a centiscale. Tell me, bacha, if I wipe off everything, if you permit me, can I wipe off? Can I? You're going to get it recording. So don't try to copy this and think that your learning is over. Your learning becomes over when you go through the video and then you make your notes. ऐसे learning नहीं होता है. अभी जानने का time है. आइए क्या देखते हैं इसमें. Number one learning that we understood is, if ever in future we need to understand degree Fahrenheit, it is always 1.8 times of degrees Celsius plus 32. And if you want to be the smart boy in the town, then you take it as how much? 2 times of degrees centigrade plus 32. और उल्टा करना है तो पहले not 32. 32 is difficult to calculate. 30. If you are the smart boy, this is the smart boy. Okay, sir, will this have any relation to our exam? Not at all. But if you don't know this, then you are super idiot. Okay, let's see Kelvin. We say 273 Kelvin stands for 0 degrees Celsius. That means 0 Kelvin, and in Kelvin don't write degrees. 0 Kelvin is minus 273 degrees Celsius. Okay, a Kelvin scale is a 100 graded scale, and so is this also a 100 graded. 100 graded. As such, a delta T measured in Kelvin will always be same as a delta T measured in degree Celsius. You need not break your head. This is what I had to talk about gases and temperature scale. This is just one part of the discussion. आगे बढ़े. Have you understood what is the absolute scale? The absolute scale is a scale conceptualized on the kinetic theory of matter with the concept that there has to be a temperature so low that the internal energy of the system almost ceases. No particle has any energy with it. Average kinetic energy has become zero. At that moment, whatever is the temperature is known as the absolute zero. Can we reach that? Probably not. ठीक है? Clear? चलिए. अब gases, yeah, बोलो. Anything?
Yes, sir.
Okay, yes, sir. Good. चलो. अब कुछ और चीजें gases behavior के देखते हैं. Now we are going to see gases behavior. Gases behavior. And when you talk about the behavior of gases, you're going to analyze the behavior of gases on 3 parameters, and the parameters are pressure, volume and temperature. इन तीनों के ऊपर आपका knowledge होना चाहिए. We will bring another thing into picture which is called N, that stands for number of moles. इसको भी लेके आएंगे पिक्चर में. ठीक है ना. चलिए एक hypothetical system बनाते हैं. कैसा system? Something like this. Let's say I have a cylinder and a piston arrangement. Now don't tell me what is cylinder and piston. It is like your cycle's inflation. Yeah. So this is my piston. The piston can be rammed inside. Understood? Right? This is a piston and this is a cylinder. Okay, this is my piston. Right now my piston, and let's say that some basic things. The cross-sectional area of this piston is equal to A square units. What do you mean by cross-sectional area? The area of the cross-section. Piston is always like a cylinder. So that circle, cross-sectional area means जो circle है, उसका area है A, and we have different strokes of the piston. What do you mean by different stroke of the piston? So different stroke of the piston means right now the position of the piston is somewhere here. The piston is positioned here. Right? And let me say that this position is x1. This position is x1. So at displacement, maths lagao. At displacement x1, what should be the volume of the piston? The volume of the piston should be AX1. Cross-sectional area into perpendicular length. Did you understand this? Pi r square into h. This is the volume of the piston. So if you now bring the piston's displacement from x1 to x2, you have reduced the displacement. Obviously, the volume falls down. Clear? समझ में आया? How to interpret volume in a piston? ये basic नहीं है. Basic तो कुछ और है. आ जाओ कहानी देखते हैं अभी. इस piston के अंदर what I have done, I have introduced 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 molecules of a gas. 10 molecules of a gas. Understood? Right. Okay. So these 10 molecules of a gas, as per our knowledge of whatever it goes of kinetic theory of matter, all of them have energy and they are vibrating about their mean positions, plus they are all in random motion. So this one might go here, come here, go here. This one might go here, come here. So they are all in random motion. So if I look at my particles, these particles are in motion, and that's why they have kinetic energy, and they are colliding with number one themselves, अपने आप में collide हो रहे हैं, and they are also colliding with the wall. They are also colliding with the wall. Is this understood? Right? Because we have some ambient temperature right now, and let's say the ambient temperature is T Kelvin. Ambient temperature means right now the surrounding temperature is T Kelvin. At T Kelvin, they have got sufficient kinetic energy to have motion among themselves, and they are colliding with themselves as well as the walls of the container. Have you understood? Now see, again you are starting to write. You hear the story. There's a story. समझो पहले, ठीक है? Now when they are colliding with the walls of the container, now what happens? Pressure is equal to what? Force per unit area. There is always a cross section. There is a constant surface area, and due to these collisions, what is happening? Due to these collisions, there is a change in momentum. Change in momentum means initially they had some mass into some initial velocity. Okay, before the collision, they must have some mass and some initial velocity u, and then after the collision, they have the same mass and having a final velocity v. We don't know. U can be less than v or u can be greater than v, whatever it is, but there is a change in momentum. And whenever there is a change in momentum, this momentum is changing over time. You have read this. Change in momentum over time gives rise to something which is called force. A force aega, obviously. So whenever you have a lot of velocity, with that velocity you're going and hitting this wall. So there's a change in momentum happened over a period of time. So you transfer some force to this wall. और अगर आप wall को देखो, the बेचारा wall, this is the wall. इस wall का कुछ तो area होगा A, और इस पे एक force आके लग गया F. So don't you think the wall experiences a pressure? The wall experiences a pressure, and pressure is given by what? Force upon unit area. This gives you an idea to understand how does a gas exert pressure. Every gas particle is colliding with the wall. As it collides with the wall, it loses its momentum, and this momentum is lost over a time. So whenever there is rate of change of momentum, it gives rise to a force, and this force is creating the pressure of the gas along the wall. Right? Our cylinder is in a very relaxed position. That does not mean there is no pressure. There is some pressure. एक और भाषा में समझते हैं. If I take one finger and I tickle myself once, so that's like little bit of funny. If I go on tickling twice, thrice, fourth, it starts becoming an irritation, and I say stop it. Now imagine that the tickling is so fast, the ramming is so fast that I can't even see. So what does my skin feel? My skin feels as if there is no instance when there is no contact. हर वक्त लग रहा है पेट में. समझ में आ रहा है? ऐसे धीरे धीरे लगाऊंगा तो 1, 2, तो कभी कभी डिस्कॉन्टैक्ट भी हो रहा है. ऐसे करता हूं, more speed, much more faster. This fan has got 3 blades only. But when the fan is that 3 blades means I should be able to put my hand inside when it is rotating. Now we find that the blade is omnipresent. In that case, the tickling is so fast now. I'm doing it with a very heavy speed rammer that you don't feel a moment when the finger has a discontact or a non-contact with your skin. The irritation has slowly become a pain for you. That's pressure. That is pressure. समझ में आया? Right? Okay. Now what we do, we make it a little bit more interesting. So हमारे पास ये 10 जो थे, ये 10 ही हैं. We are not going to introduce any more molecule, but what we have done is that we have reduced our piston volume. And how did you reduce your piston volume? You press the plunger this side, and now my piston has come to this position, right? It has come to this position, and I call this position as, and I say that it has come to a position called x2, and we know that x2 is less than x1, right? Original volume was what, beta? AX1. New volume is AX2. Obviously, the new volume is less than the original volume, without any doubt. Where are my 10 molecules now? My 10 molecules are still here. Right? From a 3 BHK house, we have brought these 10 children to a 1 BHK house. And all these 10 children were famous and notorious for eating your heads. They were exerting pressure earlier. In 3 BHK house also, they were exerting pressure. Now you have brought them into 1 BHK flat. Does your life become easy or harsh? अरे कुछ तो बोलो यार, I'm alone teaching out here. Have some mercy on me. Your life become harsh. What stops you all from communicating? But the first thing, your learning procedure is wrong. You're busy writing. You should be busy talking with me. Why have I then set up this big television in front of me with a speaker system? I could have taken this on the small monitor. आप लोग साइंस पढ़ते हो, सहस्रा को देखो, नो एक्सप्रेशन, कंप्लीट एक्सप्रेशनलेस फेस. अरे समझ में आ रहा है नहीं, आप डिस्कस करो, बात तो करो. You all are merciless. I'm speaking for last 45 minutes. Have some mercy on me. You should also talk. You should also discuss. And I'm trying to make it as interesting as possible. You've now brought the children in a 1 BHK flat. You've reduced the volume. So what happens to the pressure? The pressure increases. What is causing the pressure? The pressure is caused due to the kinetic energy, right? Earlier they were colliding, say they would be colliding the wall in say t minutes. Now they will be colliding in even less time. पहले भी भगदौड़ कर रहे थे, अभी तो और धक्का धक्की बढ़ जाएगा. The average rate of collision is going up. So from here comes the first very law of gases. Although your book earlier used to mention it, now they don't mention. This law was given by Robert Boyle, and this is the first basic law called Boyle's law. Boyle's law states that, अब देखो कैसा है, पहले लिखो मत. Boyle's law states that the pressure is inversely proportional to the volume, but there is a condition. अगर मैं इसको 1 BHK में ट्रांसफर करके यहां से 5 बच्चा निकाल के ले जाता, will your life become that harsh? No, थोड़ा आराम रहता. But you are complaining that sir, सरदर्द बहुत ज्यादा है. बॉयल्स लॉ के लिए हमारा पहला कंडीशन होता है, द फर्स्ट कंडीशन इज दैट द नंबर ऑफ पार्टिकल्स प्रोवाइडेड द नंबर ऑफ पार्टिकल्स रिमेन कांस्टेंट. पहले भी 10 बच्चे थे, अभी भी 10 बच्चे हैं. Another thing should be constant, that is temperature. अगर बाहर से मैं ये सिस्टम को कूल कर दूं, I am reducing the temperature. That is like tranquilizing every child and bringing all the 10 children in one room. Then also I think my life will be easy. सब सो जाएंगे. Are you understanding what I'm trying to say? Tranquilize each child and then bring them in 1 BHK. कोई problem नहीं. That means you should not touch the temperature. If we cool the temperature, then the kinetic energy will reduce. और in kinetic energy reduce means what? इनका उत्पाद कम हो जाएगा. Average rate of collision will fall down. Pressure will fall down. So Boyle's law के लिए आपको ये दो चीज हमेशा कंडीशन रखना होगा. Pressure is inversely proportional to volume provided the number of moles or the particle count and the temperature remains constant. Do you understand? Pressure is inversely proportional to volume. ऐसे भी आप देखो ना, एक balloon को you blow a balloon and try to squeeze it, reduce its volume. That time if you take a pin and you blast the balloon, ठाप से नहीं फटेगा क्योंकि उसके अंदर प्रेशर बहुत ज्यादा हो गया है. और वहीं बलून को छोड़ दो तो बलून फूल जाता है. अभी अगर आप पहले पिन मारोगे ना तो बलून फटेगा भी नहीं, ब्लुप ब्लुप ऐसा रहेगा, बिकॉज प्रेशर नहीं है अंदर में. So if we try to see this thing in terms of graph, because graph is also very important as an analysis for us in what you call engineering. So let's see it in analysis in terms of graph. ठीक है, देखते हैं आपको ग्राफ का नॉलेज है कि नहीं अभी. Let's see the graph. So we'll draw two graphs and we are trying to see the variation of what, beta? We're trying to see the variation of pressure and volume, and here we'll see pressure and 1 upon volume. देखते हैं. Pressure is inversely proportional to volume. That means my graph will come like this. If the pressure is more, the volume should be less. If the volume is more, the pressure should be less. Do you get it? How about this graph? इस रिलेशन को देखो तो, pressure is inversely proportional to volume. That means pressure is equal to some constant K multiplied by volume. This is y equal to mx format में आ रहा है. So this graph will always start from where? This graph will always start from the origin and it will give you a straight line. ऐसा plot देगा ये graph. P versus V will be like this, P versus 1 by V will be like this. Because with one, another way simple to understand, see, with 1 by V, it is varying directly, but with V, it is varying inversely. Do you get the mathematical funda out of here? With 1 by V, pressure varies directly, and with V, pressure varies inversely. This is called Boyle's law. ठीक है? तो इसके बेसिस में हम क्या लिख सकते हैं? What is the formula that we can design based on this? The formula that we can design based on this is something like this. Just see, so that we can help in our calculations. The formula that we get is P is directly proportional to 1 upon V, which means P should be equal to some constant K multiplied by 1 upon V, which means if you multiply pressure and volume, you always get K. In other words, we say pressure volume is always equal to PV is equal to constant. This is Boyle's law. And this helps us solve problems. If at P1 pressure, I had a volume V1, and if at a pressure P2, I occupied a volume V2, then both these should be equal. है ना? All the PVs should be equal. All the PVs. जब ये देखो कहाँ गया? What does this mean? This graph mean? The graph means this. This graph means this. It's like this. How do you read it? When my volume was V1, my pressure was P1. At a lesser volume, I have more pressure. 1 into 6 is what? 6. At a greater volume, that is 6, I have a lower pressure, 1. Again, it will be 6. So PV equal to constant. तो आपको प्रॉब्लम ऐसे देगा, आपको एक प्रेशर दिया रहेगा, एक और वॉल्यूम, this and then say what was the initial volume of the gas. However, in Boyle's law, you do not need to break your head because यहाँ टेम्परेचर नहीं आ रहा है पिक्चर पे. And when temperature comes, that Kelvin factor will come. That demon will come because they'll give you temperature in Celsius. But in this law, there is no temperature. All you need to remember, and you should not forget, ऐसे ही सोच के देखो, कभी भी प्रेशर बढ़ाओगे तो वॉल्यूम कम ही होता है. All you girls, you are known for traveling heavy during vacations. So what do? In order to reduce your suitcase, what do? You sit on the suitcase. So you are giving more pressure to the suitcase so that the volume can be made small. So pressure increases, volume reduces, and number of particles should be same. You don't want to compensate with your clothes. Your mom or dad might be saying, "Do jeans kam kar lo." No, I will take all. So number of particles constant, and mom dad cannot frown on you, beta. So temperature remaining constant, pressure is directly inversely proportional to volume. ये है Boyle's law. समझ में आया? Clear? ठीक है. Very good. कम से कम कोई, हाँ बोलो सर।
Constant, like is a constant, is there a name to that?
नहीं नहीं, कोई नेम नहीं है, ये तो मैथमेटिकल रिलेशन होता है। जब भी कोई चीज किसी चीज के साथ, कोई भी चीज किसी चीज के साथ डायरेक्टली प्रोपोर्शनल होता है, वी से, बिकॉज हैव यू गाइस स्टडीड डायरेक्ट एंड इनवर्स वेरिएशन सो फार इन लाइफ? नो, you have not yet studied. You have studied in grade 10. So in direct variation or inverse variation, we always say that if you want to replace this, the sign of proportionality with an equal, you have to introduce a constant.
Oh, okay.
Okay, you have to introduce a constant. You studied this, but the problem is that you don't remember this because you are always busy in writing what I write. I wrote in Boyle's law, Rama defeated Ravana. You also said yes, Rama defeated Ravana. साइंस ऐसे थोड़ी पढ़ा जाता है, साइंस सोच के पढ़ा जाता है। कितना टाइम है, थोड़ा सा डिस्कस कर लेते हैं, आजा। Our next law that we see on gases. So अभी तक क्या देख लिया बेटा? अभी तक देख लिया बॉयल्स लॉ, ठीक है। ये आपका बुक ये सब बताएगा ही नहीं, ऐसे वो प्रॉब्लम दे देगा और आप फंसते जाओगे। बॉयल्स लॉ, बॉयल्स लॉ किसको कनेक्ट करता है? प्रेशर और वॉल्यूम को। PV इक्वल टू कांस्टेंट इज बॉयल्स लॉ। मींस व्हेन सॉल्विंग प्रॉब्लम अंडर टू सिनेरियोस, P1 V1 should be equal to P2 V2. ये है बॉयल्स लॉ, ठीक है। And in remember that in gaseous behavior you are playing with three fellows: pressure, volume, temperature. In the first law, temperature does not get any role. However, temperature gets a guest appearance saying that the number of moles should be constant and the temperature should also be constant. You cannot change them. ठीक है। आते हैं next law में, and our next law is known as Charles law. This name you will find in your book, Charles law. Charles law is going to introduce volume versus temperature. Volume versus temperature. आप सोच के देखो, पुराना पिस्टन को फिर से ले आते हैं, ठीक है। आ गया फिर से, let's bring my lovely piston. Okay. This is my piston, and my piston is initially at a position x1, right? And at x1, obviously, I have a volume. X1 gives me a volume which is V1. Okay, X1 is giving me a volume which is V1, and all the notorious 10 kids are inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all the notorious kids are inside. That means the number of yes sir, please sir, please sir, the number of moles is kept as constant, which means the same number of moles, 10, right? And say at this position, at this particular x1 position, अभी भी तो सिलेंडर में कुछ प्रेशर है, कुछ तो प्रेशर रहेगा, right? We have kept it here. These children are making noise. The pressure is P1. Have you understood? At x1 position of the piston, the volume inside is V1 and the pressure is P1. Now what you do, you start increasing the temperature. अब temperature बाहर रखो, right? As you increase the temperature, इनके अंदर क्या होगा? Energy बढ़ जाएगा और सर दर्द होगा आपका, right? So your headache will increase. That means the pressure is now going to increase. Isn't the pressure increasing? The pressure is increasing. But we have a condition that our pressure should remain constant. Sir, you want pressure constant, number of children constant, and you are going on exciting them. How can the pressure be constant? I don't want my headache to increase more. The only option left with me is that I allow the piston to expand करके। इन बच्चों को 1 BHK से 3 BHK में धकेल दो, कम से कम मेरा सरदर्द तो घटेगा। Don't you see in some birthday parties what your parents say? Children, you'll go inside and talk. They allot you some extra space so that the headache comes down. Have you understood? आप अभी पिस्टन को कहां पे ले गए? आप पिस्टन को अभी ले गए x2 पोजीशन पे, x2 पोजीशन पे, where x2 is a larger displacement than x1, so obviously v2 should be larger than v1. Yes or no? The volume. So what is the relation you get? that as you increase the temperature and if you want the pressure to be constant, so as the number of moles also as constant, then the only way is that you have to allow the volume to increase. अगर आप वॉल्यूम को इंक्रीज होने नहीं दोगे तो प्रेशर कांस्टेंट नहीं रहेगा. 1 BHK के घर में बच्चों को और कैडबरीज दिए जा रहे हो, बच्चे तो और हल्ला करेंगे. आपको हल्ला कांस्टेंट चाहिए तो फिर बच्चों के लिए रूम बढ़ाओ. हैव यू अंडरस्टूड? सो चार्ल्स लॉ हमें क्या बोलता है? वॉल्यूम इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर, which means volume equal to some constant K into temperature, which means V by T as a ratio will always be constant. That means in problem the scenario we will get is, an initial volume V1 with a temperature T1 is same as a final volume V2 with a temperature T2 VT. पर इसके लिए एक कंडीशन है, do not increase the number of moles and ensure that the pressure is also constant. Did you understand? Before you go, 2 more minutes, because next class I won't get that pleasure to tell you. So this is all about Charles' law and the lovely implementation of Charles' law. देखो, one of the lovely implementation of Charles' law is the gas balloon, the hot air balloon. यहां से hot air blow कर रहे हो और यहां से जा रहे हो, right? See the hot air balloon funda. The pressure that is exerted on this balloon is the atmospheric pressure that is working. Constant है आपका, right? The amount of gas inside is also constant. You are increasing the temperature, therefore the balloon is expanding, the volume is going up. समझ में आया? अच्छा, तो क्या हो गया सर? हम ऊपर कैसे पहुंच गए? क्योंकि डेंसिटी इज इक्वल टू मास पर यूनिट वॉल्यूम. As you are increasing the volume, the density is falling down, and when density falls down, you are becoming lighter. गैस बलून ऊपर जाना शुरू कर दिया. This is Charles' law. What is the funda of floating? Always a less dense thing floats over a more dense thing. तो आपका बलून पहले तो बड़ा भारी भारी लग रहा था, खूब गैस भरा, गैस भरते गया, गैस भर के फिक्स्ड अमाउंट ऑफ गैस, खूब गैस भरा नहीं, खूब हीट करना शुरू किया. एंड देन यू इंक्रीज द टेम्परेचर, इंक्रीज द टेम्परेचर, इंक्रीज द टेम्परेचर, धीरे धीरे इसका वॉल्यूम बढ़ना शुरू हो गया. जैसे ही वॉल्यूम बढ़ा, इसका डेंसिटी उतर गया अपने आप ऊपर. और फिर यहाँ से वो कार्टून में as you say, सुनियो डोरेमोन डेविसुकी, देखो हम सब ऊपर गए. सो ऑल ऑफ यू ऊपर चले गए. So if you are asked to draw a graph, how would you draw this graph now? The graph will be, your graph should look how, कैसा दिखना चाहिए? VT graph should always go straight, directly proportional है ना. पर एक कैच जो आपको अभी तक नहीं बताया, whenever you are dealing with this, they should all be in Kelvin scale. Don't do the problem in Celsius scale. Celsius scale में करोगे तो लड्डू मिलेगा, लड्डू आंसर. The problem is to be solved in Kelvin scale, but they will give you the problem in Celsius scale. ये चैप्टर में और एक लॉ आएगा इसके बाद, Gay-Lussac's law, and then we will combine. So we saw pressure volume, we saw volume temperature. The next should be pressure temperature, and then combine all to get the gas law. ये चार जान गया तो आप कोई भी प्रॉब्लम सॉल्व कर सकते हैं. फंडा शुड बी क्लियर. ठीक है, बहुत हो गया. As a single person, I cannot talk more. Otherwise, Kirtan will think whenever I go away, sir teaches more. है ना? मैं क्या करूँगा? Right. चलो.